Okay, hello students. Here again I'm back to make a video. This time I'm making a video on lesson 9.3, and this lesson is about three-dimensional rectangular coordinate system. So what I'm gonna show you is all every time we have seen the rectangular coordinate system when it is a two. So when you have an x-axis and the y-axis, so you have two perpendicular lines, and any point here we use ordered pair x and y. So that's what we have. So this is a rectangular coordinate system, which is the ordered pair. So I want to make sure we understand that this is ordered pair. But now we have three lines intersecting perpendicular. So you see this is this line which you see. That's that line and the y. I mean, this line I call it x-axis, and another line is y-axis, and the other one is the z-axis. So three lines perpendicular to each other. They form in here it is three in two-dimensional rectangular coordinate system. Okay, so that part I want to show later on. But in this case, you have three lines. They meet at a point, and then how do we? What does that happen when three lines meet? What all you see is right now you have to imagine that this is x-axis, that is y-axis, and the z-axis. So you have three planes forming here. So I'm going to show you with a little kind of I don't know whether it will be good, but still I try to show is you have to imagine that this is the positive axis, the dotted is the negative axis. This is the y-axis, the dotted is the negative y-axis. And the z-axis is perpendicular to both of them, x, y. And where is the xy plane? Now here, this is the xy plane that you see. The whole, in this case, there is the xy plane forming from this side, see? So something like this. So this kind of a thing is like a xy plane. And then you see this part is like from here, is like this way. That's the xz plane. So kind of confusing. And then if you see this part, y-axis and the z, something like this. So this part, this one, or I can show it like this. So this part is like here. So there are three planes getting formed because of this lines. So what I'm going to do is I model this with the help of just a folder that I have, and you can see here. So this is the so you see there are three lines. I wanted to show this. So this is the one line x-axis. This is the line y-axis. Okay, and that's the z-axis. So you kind of have in a three-dimensional you have they form three planes. So the bottom one is the xy plane. That's the xy plane. On the left side, this is because there is an x-axis and the y-axis. So this is the xz plane, and the other one this side, this is the y and the z. So that becomes the yz plane. Can you see? So what does this planes do is you can see there are three planes. The three lines make it three planes. So these three planes divide the whole space into 8 octants. The first one is the first octant, the second octant, the third octant, and the fourth octant, the fifth octant, the sixth octant, and the seventh octant, and the eighth octant. So that's so beautiful. So again I repeat, the whole three planes you can see. I did not show you did not put it. I showed you only one side. So this side. So first octant. That's where all the x and the y. So it's so difficult to show here. It means this point, the way what I showed this point is how far away from the origin. So in order to figure out the point here, this is what we want to figure out, right? Oh, there it is, 2, 4, 7. So where is this point in the space 2, 4, 7? What does 2 means? It is the distance of this point. See this point, or distance from the y-axis. So this is the blue 2, the blue color 2 that I showed you. So that's 2 means you walk from the origin along the x-axis, you go 2. So that takes care of the first part. Then you walk 3, so the orange color 3, you go parallel to the y-axis. From here you go kind of shows 4, sorry, the 4. So it's like 1, 2, 3, and 4. So you walk 4 units along the y-axis, so parallel to that. And then comes the green color, the 7. So that means from here you go all the way to 7. So this is like 1, 2, 3, 4, 5, 6, and 7. So that's the point 7 here. Then we have a 4 and blue color 2. So what that means is, all that means is, from here, this side is 2, you can see this is 2, so I can mark a point here 2, okay, and then you go 4 along y, so you go 1, 2, 3, and 4, so kind of you go this side, so this is the point, so this is the point which is, this is 2 and 4 right here at the bottom, okay, and there is z 0 at that, on the xy plane the z is 0, okay, and then you have to move up, so that means if I have this marker, so, or maybe this one, this 7 is quite a long one, so that point is, this is 2, this is 4, and kind of 7 is something like this, so that's the point. If this is 7, so that's the height or along the z. So this green color is the distance from 0 to 7 there. Okay, so now, so before what does geometrical interpretation is, what does this point do? Let's see. I'm going to show you something. So first is, let me conclude. You have a first quadrant, octant, not a quadrant, octant. First octant, second octant, third octant, fourth octant. Then you go at the bottom. See, this is, even though these are x is positive, x is here positive, then y also is positive, but the z, so the z is negative. See, this part is down, z is up here. If you go on the other side, and you can see that, so this side is the x becomes the negative, and the y is positive, and the z is negative. So kind of nice to understand this. So first, second, third, fourth. Now I'm gonna take this off. We know what is going on here. And the question is, what does this point represent? So we know in space that's the point. Now I'm gonna try to make a 3-dimensional figure here. This height, exactly like 7, I'm gonna draw 7. Okay, so I'm trying to do. Then this orange color, so from this orange color I'll join this, which is like this is like 4 there, so this is, that okay? Then this is 2, so I use a blue color to show that it is like 2. So this is something else, see? So this has to be little above, so this will be little above here. Okay, am I making it okay? Okay, yeah. So it becomes difficult, but I'll try my level best. And then we have, so this will be 2. So the 2 will be from there. Yeah. So this is 2, exactly something like this. Okay. Is that okay? Does it look good? Okay, and the next is I have to also have a 2 this side. So this point, let me take this off, and parallel to this, okay, 2, and then I'm going to do 2 this side also. So this has to join here, to this part, and then I'm going to join the height, okay, and then join the orange color. I hope that has little too high, so little down, this will be little down. this is, oh, that's good, okay, still not happy with this. So this is down like this. Let's look better. Okay. See, so just by using one point right here, we create a prism right there. So where is the, so we ordered pair is, this point is 2, 4, 7. So this is 2, 4, and 7. And we can also write a point is in the vector form. So the vector is from 0, use another color here. Okay, the red color, let me show. So this point from the origin O, that's like a O, origin is O, we can join this. Okay, and there you go. So you see here, like how we write vector in the component form, we can write this P, call it as P, and say, okay, vector OP, and this vector OP is 2, 4, and 7. Okay. So the point here P, the blue point is the ordered triple, not ordered pair. Here this is ordered triple, here this is ordered pair. But to write in the component form that, or you could also write, this is also called a position vector, that you go along this, so there is a unit vector along I here, I cap, so we can write this as 2I, plus then you have the, along this we can have, that's the J cap, see, this is the J unit vector, we can write it here also, this is J, so there are 4 pieces, 1, 2, 3, 4, that's 4 times that, so it is 2 and J. And then finally we have along this, there is a K cap, so this is something new. So there are 3 vectors, one blue vector, red vector, K vector, which is the unit vector because their magnitude is 1. And then accordingly we know how much is the scalar multiplication of that I. So it is 2I. I messed up here, this is 4J. And then this is K. So K cap is the unit vector, so it's the direction showing you up here. So one is this is the vector which is along this. Then you go this one along another vector, and then you go from here to here, and then finally you get the dotted one, which is this one. See, OP, and that one is 7K cap. So these are. So either you can write this as with cap, or you just write 2I plus 4J plus 7K, and you're done. So any point in the three-dimensional rectangular coordinate space, so now in this case vector coordinate system, but still we say in the whole space any point can be represented by ordered triple, and you can also create a prism there with the help of those ordered triple. But the point, in this case it is 2, 4, 7. Now comes here, look at this, another one is showing is, before I finish, any point in the space, this is a classroom, I'm standing here, and if you see at the corner, I don't know, you can't see it, but if you see that corner, if I want to know where is my tip of my head, so it's like we want to know, okay, if you see me, I just want to model this with the help of this. So if I'm standing here, and I want to know what is my order triple here. So all I need to know is what is my distance along parallel to the x. Suppose I call that as the x-axis in this part. I can say this is the x-axis, this is the y-axis, and that's the z-axis. So I want to know, if I want to know how much away from so if I want to know where is my tip, I have to say, okay, that's the distance. This is that x, correct? And I want to know how far, what is that y? I have to know my tip how far from here to the wall. So this is the x, this is the y. So again I repeat, this is the x, this is the x. It's the distance of on the x-axis, my head, how far away from this xy plane. Okay, and then finally I want to know what is the z, like from the base, how high is my what is my height, and that's like 5 feet, maybe 5.5. So and you can write, okay, if I want to know here how far away from here, oh, that's like 2 feet. So you say, okay, it is 2 feet, and then I can see how far away from the x-axis or the xz, because that's the z. So that will be like maybe 4 feet. I put like a 4 feet, and I'm 5.5 that I know. I'm really 5.5. So kind of understanding what does that mean. Any point here right now, and I'm standing, this point has order triple. So it always has 3 points. Every point in the space has got order triple. Now, here is another example I want to show is, before I come to this example, I hope you guys got that. So any point set of ordered pair, set of ordered triple, so I'm going to, set of ordered triple is, this is the set, I'm using braces, it means it is x, y, z, so you have x coordinate, y coordinate, z coordinate, where x, y, z all belongs to, belongs to, these two lines means it's all real numbers, no complex numbers. Oh, I'm sorry. I'm gonna go back here. Okay, so as I was saying that, so what is the meaning of set of ordered triple means, set means the braces I use, this is x, y, z, where x, y, z belongs to, all belongs to, this is belongs to, that's the real number, all real numbers. Another example is given is -4, 3 and -5. So I was showing you that -4, 3 and is, if I model this again, so you want to know where is -4. So if this is x-axis, sorry, yeah. So if this is x-axis, the other side is the x-axis. So I have to say, okay, you go 1, 2, 3, and 4. So that's how I say. So you go 1, 2, 3, and 4. But that's -4. So that's where I am here, right here. And then you have to go 3. So along the y-axis it is 3. So here this way it is 1, 2, and 3. So that's the red color here which I showed. Oh, here you can see this part. That's 3. So this is distance 4. Then you go. This is 3. That's 3 because there is a 3 right here. And then you go down. That means, so now you know from top. So you're on top here. It was -4. This was -4 right here. That's -4 right here. Okay, and then where am I? Yeah, sorry. Yeah, this is -4, and then the 3 is right here, and then you go down. So you have to go down like this. How far low you go is -5. So from here you go down. That's what it is. So from here, 4, 3, and then go down. Can you see? I think you can see that part. It means if this is 5, so it's like this, because it's 4, -4, and then it is -3, 3, and then down, and that's how we get a point here. So if you see the figure right here, you go, so -4, you go blue color, then you go 3, the orange from here, and then you go down. This is the point, and I call it as Q, and the point is -4, 3, and -5. And using this, I also formed a prism. Look at that. So each one of this is 5, 5, 5. This is 5. So the green ones are 5. This is 5. So 5, 5, and this is also 5. And this is 3. So that's like 4. This is 4. This is 4. This is 4. Like this. That's 4. And then the 3 is the red color. This is the 3. Okay, I hope, and you can just make a prism out of it just by knowing where this point is. So where is the vector then? The vector starts from the origin. So there I can directly join from this point to here. And I want to use maybe a color I can use. Yeah, let me see. This is the vector OQ. So the OQ vector is either you write in the component form, or you can write it as negative 4i plus 3j and 5k. That's it, done. Okay, and then I also wrote here, just to understand here, what does this mean is, in two-dimensional rectangular coordinate system, equation in x, y represents a plane now, represents curves in the plane. Now, remember, in two-dimensional, anything like this, we always have seen anything equation in x and y, either it is a line, or it is a parabola, or it is a polynomials, or it is a sine graph, or it could be a inverse function, tan inverse of graph. So anything like this is possible. All those are like curves. That's what I'm trying to say. But in this case, if I want to have an equation, they are called. So in the triple space, it's going to be not the curve, but they are going to be surfaces. That's what I'm saying. So in later classes, you see anything in equation, you may get something like this: x squared plus 5x minus 5y plus 2 equals 7 2z. So kind of could be, if all are same, let's see, if everything is like 2x minus 5y plus 7z equals 8, this type of form without any square, you will see they are just, it's a plane. And that's what I'm going to show in the other side. One more thing I forgot is, what happens on different planes. So I'm going to draw that, but before I go to draw this, again I go back to this. Where is it? Okay, here. This is the first octant. Remember, there's a nice thing going on here. So let me go directly to. Okay. So if you see, if this is x-axis, so this is the x-axis, and this is the y-axis, and this is like you see there's a plane xy at the bottom, so this is the point. There is no z, you're not going up, you're not going down. So any point here, let's say if I have x, y, z, so it will be always x, y, and 0. So that's such a nice thing is at the bottom part. So any plane on the x, so this is x, y plane. So this becomes x, so this is x, y plane. Now the y, z plane, so this is become the, look at it, this is y, z plane. So what is y, z plane means, you don't have, the y, z plane you won't have, sorry, I made a mistake. This is the x, z plane, because this is the x, right? So x and the y and the z, x, z plane, you will see there's no y, this is the y. So there's no y coordinate, so it is like x, then 0 and z. So that's how it is. So anything here, anything over here, this is the x, z plane. This is the bottom. So I wanted to get this before we go beyond rigorous topics. The bottom is xy plane. This is xz, and the other one, this one is yz. So where is the yz is? So this part. So this is yz plane, and you can see in the yz plane over here there is no x. The x is just that either you go y and z. So there is no x there because you're not going on the positive or the negative x-axis. You stay. So the x is 0 and you have y and 0. Does it make sense? Confusing. Now let's see, we will try to take a simple equations. What is the meaning of, let's see, y equals 3? What does this 3, what does that represent? So that's what I'm going to show on the other side. Okay, here it is. So I have some figures here to show. Okay. So what is the meaning of? I'm going to take this the easiest one, the z. What does z equals 5 means? Okay, so maybe 3. Let's put it like a 3. So all this means is your 3 is fixed. So this x, y will be having lot of numbers changing, but the z is 3. All that means is I can figure out where is 1, 2, and 3. So that's the 3. So I can draw a plane like this. Okay. So that exactly goes something like this. So that's the point. This plane slices, so you don't see this. So this one is 4. So this plane goes through the point like this. I hope that makes sense to you. Yeah. So what does z equals 3 basically mean? It's the plane parallel to the xy plane. See? So this is the plane that basically parallel to the xy plane, but it goes through the point 3. I hope that makes sense, and I wanted to show this. So this is on the other side, right? So this one to show. So that way, you have to really imagine this, right? So this is like a plane, z equals 3, where x and y could be anything. But if I want to write what is x equals, let's see, what is x equals 4 represent. What this means is the x is 4 and y and z can be anything. That way I have to say 1, 2, 3, and 4. So it has to go through this. So I'm gonna draw a plane. I'm gonna draw a plane through this point. So it means I have to do something like this. I don't know. I'm doing it right. So this one. So this is the main focus point. Is this one? Okay, that goes the other side. So this is a plane which doesn't look good. Let's see if I can show. Maybe I think I can change something like this. This will be better. So it means, there you go. Okay. So it means the plane is just passing through 4 here. That's the 4. 1, 2, 3, 4 on the axis. So this plane is parallel. So this plane, what you see, it is parallel to this one. See, this is a so this is the YZ plane. See, so YZ plane, and that's why I say YZ can be moved any point. Its YZ will be changing anywhere over here, but its Z will stay the same. Okay, so that's why I say x equals 4, and then finally we'll do what about y? What about y equals 5? So I can take 1, 2, 3, 4, 5 here, and then here I can graph it like this. So again, it's not perfect, but just to show that that's the plane. Now, this is the plane which should be, okay, I'm trying to make it parallel to the other one. So this won't be good enough. So I think I better draw like this. I wanted to draw parallel to, okay, I think something like this, something like this. So this part is on the other side, so I'll draw to show that that's on the other side, because there is this is y, this is x, this is z. So naturally this thing is parallel to here. So here y is 5, like this. this kind of a plane. So that plane, what I did is, it's the plane that just crosses the point 5, and it is parallel to xz plane. This is the xz plane. So any point here will be having the first x and y will be changing, but this will be fixed 5. Okay, I think I forgot about this one. Yeah, this one, correct. So that will. So the y is fixed. So this is fixed. So any point over here on this point, the y coordinate stays the same, and that plane that goes is parallel to the xz plane. Look at this. This one is parallel to yz plane, and this one I think I did not show is parallel to. If I try to draw, let's see. So it is parallel to xy plane here. So any point here can be any point. This point is always x and y stay. Oh, there you go. I already written down. Okay, so this is what I wanted to show. So the next one more thing is, what if you have 2 points here? You know the distance formula for distance. If you have 2 points, I'm just picking any 2 points. Let's say this point. We can find the distance from P and Q by using the formula. What is the formula? Is if this one is x1, y1, z1, and this is x2, y2, z2, we can extend the same formula that you have for the 2-dimensional, that is x2 minus x1 square plus y2 minus y1 plus z2 minus z1 the whole square. Or it is as good as doing exactly like what we did, also using in the vector form. So remember, if you had a vector like this in the two-dimensional, if you had a vector which was like a1, a2, so what we do is, it's just the square root of a1 square plus a2 square is the magnitude of that vector pq. This is pq magnitude. You just put a square root and the position vector. And the same thing is this one also. So you take the square root of pq and you get the answer. Now finally, if you want to know, on Monday I want to show a lot of problems on this to find you can also find the midpoint formula also, where what is the midpoint formula? It is x1 plus x2 for the 2-dimensional. All you do is you add one more and then you divide by 2. So y1 plus y2 plus y3 and divide by 2, and that's how you find the midpoint of the thing. Let's go to the last one. What if there was a sphere? If there is and that's the last one. So if this is a sphere, so this is like a ball, basketball, and maybe I'm using a exact location, maybe 4 and 4 and 4. Okay, and it's like a black mark. Now this one. Now see, look at it. So this is like a ball. It's a basketball, something like this. Right? Okay, kind of that. So if I want to figure out how much is now this is what I'm talking about. In 3-dimensional, it's a surface, right? Every point on the sphere is like a point, and then we know the equation of the equation. What is the equation of circle? So equation of a circle in general form is, or central form, x minus h the whole square plus y minus k the whole square is the radius square. So that means if you have 2-dimensional figure and there is a circle and this is the center hk and this is the radius, so if I want to find what is the equation of this, that's it. But here we have a 3-dimensional. Look at this. If the point is, I'm just taking an easy one with the x, it could be anywhere around in the space. And for this one, what if this point was somewhere else? I already have drawn it. What if it was somewhere here? You see. So what if this was the case, then so this point will be K, and I can use some other point G like this. So then you can, then we can extend this formula and say, okay, now it is ax minus square plus y minus k the whole square plus z minus g the whole square equals the radius square. That becomes the formula. Just extend from 2-dimensional to 3-dimensional, and if the radius is 4, the way I have given here, everything radius is the 4, this is the 4 I took, right? So that's the 4 origin, the hkg that I took here is the origin. So this whole thing reduces to x square, y square, z square, and the radius is 4, 4 square is 16, and that. Okay, so on Monday, what are we going to do is we'll do something problems on midpoint formula and how to find the distance. We are also going to find out if you have, and that's the last one, and I'm done. So if we have like this is the x, y, z, and there is a basketball. Let's see, this is the okay, and if this is the one, and there is a point here, then there is another. The thing is, there's a, let's say this part that it is sliced by a plane parallel to the xy. So this is x and y, and I want to know, okay, so I want to cut this piece. See this part? I want to cut this circle. It goes like this. So when you cut this sphere, what's going on is you're going to get, when you slice this, so you're going to get a circular, see, something like that. Can you see? So when you slice this whole chop off with a slice with a plane, you get a round circle. So our question, we want to trace what is this. Like I can cut it at maybe here 3, and this equation I can give some point, maybe 2, 4, 5. The way I've drawn it, it looks like it is on the other side, maybe -2, and maybe 3 this side, and then 3 and 1. Let's see. So that's like your h, k, and g, right? So, but what happens is, because this is sliced by the z here is that's the z along the z is 3, right? So this is 3. So the equation will be, so this equation you have to put it is like x, the way I'm showing is h, k, and g. This is like h, k, g. So this will be x plus 2 square and plus y minus 3. That's the equation of the whole thing here. Z minus 1 the whole square, and the radius, and that radius you have to figure out what is that. If you just take the from here, you have to figure out what is the radius, and then we find out z here. Z is 3, so the y, sorry, so it's parallel. Am I making slight mistake here? Just wanted to show 2, 3. Oh, I'm sorry. This one is 3. This should be 3 here. And this, let's put it like a 2. Maybe this is like a 2 here, 1 and 2. And this is also, I took 2. This, let's take that as -3. This is -3, because that will go as -3 there, and then I'm going this one as 2. This is 2, and that one is 3. Okay. So the reason I changed it because I already had this 3, and that's why I'm kind of made a mistake. So when it is parallel to this, see this point, this one goes, this is 1. So this 3, where is that? This will be, I'm going to change this. This is opposite of minus is +3. Opposite of this is -2, and this is -3. So if it is passing to this, that's z is 3. So z is 3 here. So when you put a z equals 3, so this will be 3 minus 3, and whatever the radius, okay. So this radius we have to find out whatever the radius is. I'll just put r square. You'll have to figure out that. And then what happens is this whole thing collapses. So when that thing collapses, you get x plus 3 the whole square plus y minus 2 whole square is whatever the radius. I'll put r square here. So it's like a circle. Now what does this means is the trace of the circle. trace of the, so it means this one only, because the whole round is like a hollow sphere. So when you slice it, you get a circular trace there, and the equation of that trace will be this one, and whatever the radius is. So on Monday we'll do a lot of problems. I didn't wanted to show now, but just to get an idea. Okay, there is a ball there, the round, and it has somewhere at the, it is at some point there is a center to that. Center is -323, and then you can create an equation like that. And then because if you slice, if you want to notice the trace of that, then because it is z equals 3 here, you just plug in z is 3, 3 minus 3, that just goes away, and that's what you get. Okay, long video, hope this helps. So I just wanted to share a lot of information, three-dimensional, and then once we are doing, okay, is not just finding out this trace, and after that we are going to do is the final part is called A cross B cross C. So first part is what is A cross B vector. So this is called going to be cross product, and then we are also going to have dot cross product. It is A dot B cross C after that, and then finally we got this. That's the next one. Okay. Then, and again, keep watching. I like to show the concept clear. You may not understand. Maybe it was like a little shabby, not perfect, little messed up, and could be. But still, I just feel excited to show whatever I know, so that you guys really get this when you go to the university, so that you really get everything. High level vector space, it's not just this, so we have to go beyond, and there's so much to learn on this. Take care, thank you for watching, and hard work paves way to success. You work hard, you get it. Or you make choices, not the others. You spend time at home, be with you, and you can do it. Just spend time and you will do it. Don't give excuse of this one. In Latin it says exercitatio est maximus magister. Practice is the best teacher. No matter how much I do here, it won't help. Okay, so bye. Take care. Good night, and have a good weekend. Today's Friday.